Hi there, I'm Mr. Orr, and I am back with some additional videos for you. Geometry, we're going into Chapter 6 now, and this will be Section 6.1. I'll do as many of these as I can today until my voice gives out. As you can probably tell, I have a bit of laryngitis. So let's see what happens here. Section 6.1. A polygon is a figure that is in a plane, flat surface, and it is formed by three or more segments called sides. There are some specific conditions about polygons, what can and cannot be a polygon. So let me just demonstrate a bit here. This is not a polygon. This is not a polygon, although you could consider it to be made up of two separate polygons, but it's not a polygon because these two sides cross each other. This is not a polygon because it has a curved side. And of course, this is not a polygon because the sides don't meet. So polygons can be any number of sides. So the smallest number of sides would be 3, a triangle. You can have a quadrilateral, 4. You can have a pentagon of 5, and of course the most famous pentagon is the one in actually Arlington, Virginia. A 6-sided figure would be a hexagon, a 7-sided figure a heptagon, an 8-sided figure an octagon, like a stop sign, a 9-sided figure a nonagon, 10 is decagon, and 12 is dodecagon. Those are the most common ones. The ones you should know certainly are triangle, quadrilateral, pentagon, hexagon, and octagon. Now, a polygon can be convex or concave. A convex polygon is one in which all the sides, all the angles point outward, like this, this, etc. However, a concave polygon would be one in which there is a cave in it. Okay, and now it's not convex anymore, and all it takes is one cave, and it can be a very small cave. So you can have something like this, and it's still concave. All right? Now, a polygon can be equilateral if all of its sides are congruent. It can be equiangular if all of its angles are congruent. And if it meets both conditions, all sides and all angles congruent, then it's considered to be regular. In my classes, many of you are familiar with this formula, n minus 2 times 180. And what that means is that the number of sides minus 2 multiplied by 180 will give you the number of degrees in all the angles added up together of the polygon. So in this case, this is a 5-sided figure. So it would be 5 minus 2 is 3 times 180 is 540. So all of these angles, interior angles, added up together makes 540 degrees. That does not, of course, guarantee that they're all the same. For that to be the case, it has to be regular. But at least this will tell you how many degrees in all the interior angles. So if you think about that, it's pretty logical. If you have a triangle, you have 3 minus 2 is 1 times 180. All these 3 add up to 180. If you have a quadrilateral, 4 sides, 4 minus 2 is 2 times 180 is 360. And that certainly makes sense. If this was a rectangle, these would all be 90, and 4 times 90 is 360. A 5-sided figure, a pentagon, like this perhaps, 1, 2, 3, 4, 5 minus 2 is 3 times 180 is 540. So that will tell you any number of sides. As long as you have the number of sides, you can determine the total of all the angle measures. Let's see, what else do I want to say about that? I think that's all you need for this section. So there was one interesting problem here that we did, And I will go over that with you here because I rather like it. It is really two trapezoids that are connected with a common base. And this is 3y, 3y. This is down here 3x and 3x, 3x. And here you have 4x plus 5, 4x plus 5. And these two are 3y minus 20 and 3y minus 20. Now, if you add up all of these angles, you know this is a four-sided figure, so they're going to add up to 360. So that would give us 6y plus 6x equals 360. And I'm going to simplify that by dividing everything by 6, so I get y plus x equals 60. Okay, there's one of the two equations that we need. The other one we'll get down here. All of these four have to add up to 360. So that these two together, that would be 8x plus 10 plus 6y minus 40 has to equal 360. So that would give us 8x plus 6y. Let's see, this would be plus 10 minus 40 is minus 30. So I add 30, I get equals 390. Now I'm going to divide by 2 to make it simpler. So I get 4x plus 3y equals 195. I'm going to take this one, let me turn it around first, so I get x plus y equals 60 because I have the x's first over here. Now I'm going to multiply this by negative 3. So that gives me negative 3x minus 3y equals negative 180. Now I can add the two equations. This is the method sometimes called combination or sometimes called elimination. And here we have, so now we add the two equations. We have 4x minus 3x is x. These cancel, equals 15. Take that 15 and put it back into one of these equations here. This one is the easiest. 15 plus blank equals 60, so y equals 45. And that's the solution to that problem. Requires some algebra, which I like because it reviews some of your algebra from previous courses. And I think we'll close with that for section 6.1. I'll be back shortly with section 6.2.